Now we're recording. So what are the plans tonight? So hopefully we're going to have some fun tonight. We're just going to basically go through a few questions, and there's only 3 questions I wanted to tackle tonight, but one of them actually will probably take a good chunk of the session. But before I do that, let's jump into a few slides just to get us going. There we go. Stuff. Let's start with some stuff. Hopefully you can all see me reasonably well. So the reason I started with this slide is not for ridiculous over-the-top self-promotion. It's more the fact that I had a number of people ask me for ways of getting in touch with me, and especially when it comes to conferences in terms of slide content and the like. We used to put it on asktom.oracle.com, and we still do most of it, but it seems to me that SlideShare and those kind of forums have become the place where people go to. So I wanted to standardize on that. And when I did that, I took the opportunity to try come up with a nice, simple naming standard such that if anyone ever wants to get in touch with me, it's very easy to remember. So they're all bit.ly links. And as you can see, that's a fairly simple standard. I come up with bit.ly. My blog is blog-Connor. My YouTube channel is YouTube-Connor. The recording of this session, now that I've remembered to hit record, that'll be on probably in the next couple of days. If you miss or have to leave early, or basically start you thinking it's 5 days before Christmas, and what am I doing at an office hours session? My Twitter handle, same thing. You can get Twitter-Connor. And for those who use other forms of social media, I've just come back from Sangam, and India, Facebook is probably the most popular social media form. So I've got a bit.ly link, Facebook-Connor. I've got LinkedIn-Connor. I've got Instagram-Connor. I have to admit there's not a lot of technical content on Instagram.Connor. And probably the only one that really anyone cares about is SlideShare-Connor. So what I've been trying to do is all the presentations I've done this year around the world, I've been trying to go back and upload all of them to bit.ly/SlideShare-Connor. So feel free to get access to them there. Bits and pieces. The first one is I've just come back from the Sangam conference in India, which was spectacular. We had a whole stack of Oracle speakers there. Someone's on the chat line already. What do we got? Someone submitted a bug. Okay, I'll have a look at that. Thanks, Judith. I'll check that out. So yeah, I've just come back from the Sangam conference in India. We had a whole stack of Oracle speakers there, including some very senior ones, which was great to get them exposed to the Indian audiences. In Bangalore, we had Vipin, the Senior Vice President of Security, and Penny Averill, Vice President of Database. Their talks, as you can imagine, were absolutely jammed to the rafters. But the thing that I really took away from Sangam, and I recently did a YouTube video on this, but I thought I'd touch on it here in office hours, was the fact that we had these things called fireside chats. Why do I need bits and pieces up on this show? Do I? We had these things called fireside chats, which were probably similar to what they call the expert panel kind of concept you often see at conferences, where a few people sit at the front and people get involved and ask questions. Probably the majority of conferences I've been to, those things just die. Like, you know, the speakers get up in front and then the people in the audience sit there and they don't really want to put their hand up. These were awesome in India, and that's a credit to the Indian attendees. Literally, hands went shooting up, and it wasn't just myself and Chris Saxon ran one, but it wasn't just us. They ran fireside chats all day, one for Exadata, one for RAC, one for security, and people were so into it. So that gives me a lot of hope for in terms of running similar things, both face-to-face and hopefully office hours next year. You can certainly reach out to me on Twitter or drop a message in the chat. I'm tempted to think next year doing some more office hours sessions where I don't have any content. I'll just basically open up the forum and we'll even maybe turn all the audio on and see how we go, see if we can manage it virtually, and just try fireside chat along those lines. We might try so. So if you think that's a good idea, you know, throw a comment on the chat or reach out to me on Twitter and drop me a line. If you think that's probably going to be a disaster, also let me know. I'm just curious on your thoughts. The second thing I wanted to talk about is next year in January in terms of what I'll be doing. So just a little bit of advertising. If you're in Israel, I'll be at the Israel user group at the end of January doing some talks there at that conference. Or if you're in Rome at the end of January, it's pretty cold in Rome at the end of January, but I'll be there for the Italian Oracle user group. So that's just a shout out to those 2 events. That'll be a first for me for both of them. So I can't wait to go. So if you're in Israel or in Rome, please come along and say hello. If you're at a conference, if you're at the conference there, please don't just come to my talks, come and actually say hello. Let's have a chat. It'd be great to always put faces behind the people that take their time to come visit me on office hours. That'd be cool. And the last thing I will say is this is the last office hours session for the year across the whole board. And just to let you know, and this is me just being a little bit proud on behalf of the entire office hours group that have put together, this is the 183rd office hours session this year. Now, given that we started in February, that means we've averaged more than one every 2 days. So hopefully you've got a lot of benefit out of them. I'm super proud of the fact that that is 180, for lack of a better term, webinars that we wouldn't have otherwise have done had office hours not come into existence way back in February. So a shout out to my manager, Stephen Feuerstein, who was the brainchild of this and managed to garner the support inside Oracle to do it. But yeah, so 180 plus 1 hour sessions to the Oracle community for free. So hopefully you're as chuffed about that as I am. Let's go back to my slides. Let's share the screen again. So this is what we're going to talk about today. There's only 3 questions, and the first 2 of them are actually fairly quickly. And the last one is the one I'm going to spend some time on. And that one's going to be an interesting trip down memory lane for me. And hopefully you'll get some value and some fun out of that as well. So the first one was handling multiple email servers. And as many people will know, as of Oracle 10, we introduced a package called UTL Mail, effectively like a wrapper around the more low-level UTL SMTP routine. And UTL Mail uses a parameter which is hard-coded in the init.ora, which is SMTP mail server, or something like that, SMTP out server, I think, which tells you what mail server to talk to. The question that came in is, well, what if we've got multiple email servers we have to talk to? How do we manage that? So we'll talk about that. The second one is an interesting one that came up. I was doing some of my own interesting research on consistent gets, and I was looking at a statistic called table scan rows gotten, which, as the name suggests, sounds like how many rows you get from a table scan. And I got all sorts of weird numbers, and I'll share with you that interesting thing because it'll hopefully give you some ideas how to interpret that statistic. And the final one is what comes after the bracket, and I'll say nothing more about that until we actually get onto it. So let's get into it. Just make sure everything's coming up nicely on screen, which it is. Multiple email servers. This is the question that came in for the office hours. We have 2 email servers. The first server can only send internal emails, and the second server can only send external emails. How can we set up SMTP out server? And I can understand this kind of logic because it's not uncommon for businesses nowadays, given that security is so important, for companies to literally have multiple or separate networks for internal and external capacities. And it's not, I suppose, unusual to have an email server managing that separation of network for security purposes. It sort of makes a lot of sense in my opinion. So I'm surprised maybe more people are doing it, but this person has a requirement of, what if I want to send email from the database and send it to either of those email servers? How do I manage the parameter? And they gave us some clarification. They said, we're using UTL Mail, and we're also using the Apex send mail process. So let's go through how we could tackle this. So I'm going to talk about UTL Mail first. And that one's very, very easy to actually solve. And I'll do it with a very simple demo. So let's, OC Mail, I got to remember that. Let's do a new share. Just make sure we can see that. Yes, hopefully the font is big enough. I'm typing around the microphone. So this is what I got set currently in my database, which is the default, which is by default, we don't have no setting for SMTP out server. It's default to null. Now, just as an aside to this, before you use UTL Mail, just a caveat for those people that haven't actually used this before in the database, UTL Mail in most versions of the database, I think all since about, well, maybe all versions since Oracle 10 when it became available, is not deployed in the database by default. So what we do is we actually ship the source code for UTL Mail under Oracle Home RDMS admin as per normal, but we don't actually put it into the database. So as a result, what that means is you can't use UTL Mail unless you explicitly compile and create the package. That makes sense because from a security perspective, you probably don't want to be giving access to anyone to go smashing out emails to the outside world. That's got like, spam central written all over it. So if you do need that, you can actually search in RDMS admin. There's two files. I didn't put them in the slides, sorry. There's utlmail.sql and there's pvrt, privatemail.plb. You need to run those two routines as sysdba if you want to load it into the database and then grant access to that package to the appropriate people. But I've already done that for the sake of this demo. So my SMTP out server is null by default. This is one of the things I discovered. You can actually set this at session level. I actually thought this would be hard burnt into a startup parameter, but you can actually set it at session level. Using that, it's actually very easy to solve this issue with UTL mail calls. If I had, for example, a routine that looked something like this, this is obviously a much cut down version of how a genuine use of UTL mail would work, but you get the idea. I've got a simple thing here which says who the sender is, who the recipients are, passes a parameter, a subject and a message. If that's the UTL mail wrapper you're currently using or something similar, all you really have to do is extend it slightly. I've set up a second parameter here you can see called p_mode. And that would be the assumption that if you pass in internal or external, or most likely you could probably work it out from the domain name of the email recipient that you're planning, but I've passed it explicitly here. You can actually see how we can very easily wrap those routines in a alter session call. So if the mode is internal, on line 10, I would simply alter session set my output server to the first or my internal mail server. And if it was, and there's a bug in my code, in line 11, it would be pmode equals external. Then we could simply do that. Someone's already said, shouldn't that be external? Yes, it should be. Stop picking on my buggy code. So yes, the second one would be if pmode equals external, you can see the cut and paste file there, then I would set the email server to some other server. And then I just go ahead and use UTL mail send. So solving the UTL mail problem is actually very, very trivial, easy to do. Just put a wrapper around your existing code. That's not a drama. So the problem now is, let's go back to my share. So solving UTL mail should be very, very easy. Apex is a different beast. If you're using the Apex mail facilities, which is pretty cool because it's done nice and asynchronously, it gets thrown into a queue and then a background job sends them off. Well, that's a bit more of a challenge because it's at Apex instance level, we actually set what the SMTP host is and the port is. So they're set obviously via the GUI, as you can see there. And that becomes, how do I manage that using the Apex mail queue? So I've got some ideas here how you could actually tackle this. The way Apex sends mail is every time you call the Apex mail package, what happens is it actually just logs those messages in a table. It doesn't actually do any mailing right there and then. What happens is there's a background scheduler job called Oracle Apex Mail Queue, which intermittently comes on every, I can't remember what the frequency is, and actually grabs everything on the mail queue, hence that table, and sends it off to the email server. In that way, we can manage things like failures and retries and logging and the like. So if you're doing your own email infrastructure, this would be a very smart way of doing it. But obviously people, as a result, leverage the Apex mail facilities to make it easier for themselves. There's also a routine inside Apex Mail called push the queue. And that's roughly what this background job will be doing. It'll effectively be pushing the queue out. But one of the things you can do is by default, it uses the parameters set in your Apex instance, but you can actually override it with the host name and the port number. So you could actually choose to push out those particular emails, with a customized SMTP server. There's one drama with that, of course, though, is if you've then called all these previous calls to email, I've now got an email queue of say 100 messages, which will have a mix and match of some internal, some external. That's a bit of a problem because if I just choose to push the queue, I can't on a message by message basis choose the SMTP server to go out to. So yes, you will need to do some wrapping again. My recommendation would be is if you create your own version of Apex Mail as an override in the local schema such that we pick up that, what that will do is actually put the messages to your own copy of the Apex Mail queue. You could actually take a copy of, I think the table's called WWV, Apex Mail messages. Take a copy of that, the structure identically. Then your version of Apex Mail will simply put messages into that one. And so nothing actually gets put into the official Apex email queue. Then you would set up a job which would actually go through your table, pick out all the internal emails. At that point, make calls to the Apex Mail API to actually put them into the genuine Apex table, just all the internal emails, and then call push queue, overriding the queue, the SMTP out server with your internal mail server. Once that's done, then go through your table again, pick up all the external ones, put them into the Apex Mail queue, and then call push queue again with the external email server. So there's a little bit of fiddling around there, but you could actually do it, I believe. So in that way, once again, it's a wrapper package, which lets you then control which particular email server you want to push these mails to. So hopefully that helps out that person, if you're on the call, about how you'd be able to do it. One of the things you can do is, even though it looks like the SMTP out server is set at the GUI level, the access to those instance settings is available also using an API. So under Apex Instance Admin, there's a package and you can call set parameter. One of the parameters you can set is SMTP host address. So you still have the same issue of actually knowing which internal emails and which ones are external emails. But if you ever need to override, just put this in for completeness here, if you ever need to override the things that you would normally set in the GUI, some of those instance parameters, they actually make a nice little API available at the command line as well. So hopefully that helps out with handling multiple email servers. There's a little bit of wrap, a little bit of complexity, but hopefully that helps. One thing I should note is, if you're thinking maybe I can just set multiple email servers on SMTP out server, no, that's not supported. 8:18, I've got to keep it on the time. Got to get done. We have to finish before Christmas. Table scan rows gotten. What an interesting statistic this turned out to be. And rather than go into elaborate slides, I thought we'd go straight into a demo and walk through it, because this one I found really quite interesting. Let's get straight into the demo. A new share. So the first thing I'm going to do is I'm going to do all this demo as Scott, a nice, simple, small user. And I want Scott to be able to query some of the $V tables. So I'm just being lazy here. Don't do this on your normal systems. I'm just saying, rather than list out the $V tables he needs, we'll just go select it in a dictionary and give him the lot. So word of warning, this is not best practice. This is office hours convenience for me. So I'm going to connect to Scott Tiger. I'm going to create a table called T, and it's, what is it? What do we get? It's 10 copies of all objects. And because Scott can't see the entire set of objects in the database, it turns out that Scott can see about 60,000 objects, therefore times it by 10, and we have 661,000 rows, give or take, in that table. Hopefully everyone's with me there. Now I'm going to reconnect to flush out all the session level statistics. They'll be reset to 0 such that we have a brand new session. And then I'm going to do a real simple query. Now, before I even run it, I'll point out there, I'm using a thing called set feedback only. That's a 12.2 feature and above of SQL+, which is nice. Set feedback only says run the query, fetch the rows, but don't actually paint them on the screen. So we won't see ridiculous scrolling and the like. So I've got select star from T. I haven't actually run it yet. Let's run it with a /. It chugs away. As you can imagine, we went and received 661,000 rows. And then I go query $MyStat, which is the session level stats, for the particular stat called table scan rows gotten. Now you're probably thinking, that is the most least impressive result I've ever seen. There's no index in the table. We did a table scan. There were 661,000 rows in the table. And hey, presto, you got 661,000 rows back on the statistic. You know, thanks for boring me to tears just before Christmas, Connor. But bear with me. So that was select star from T, and the table scan rows gotten equals the number of rows in the table. Let's now do something slightly different. I'm listing all the columns individually from T. So it's pretty much the same as select star. Let's run that. And surprise, surprise, once again, now you're getting ready to leave the call. Yes, the number of rows in the table equals the number of table scan rows we did. So far, so good. Let's now make a tiny, tiny modification. I'm selecting all the columns, and I'm also collecting one extra piece of information, the letter X, just the string X from T. Let's now run it again. This is the drum roll part. Okay, so how many rows did we scan? There were 660,000 rows. Guess how many rows we scanned? 24 million. Now that is just plain weird. All I did was add an extra attribute. Nothing from the table, no joins, no indexes, no nothing. I just added the string X, and all of a sudden it's gone from 600,000 to 24 million. What on earth is going on? So maybe, what if I don't get all the columns? What if I actually shrink down the amount of stuff I actually want to get? So rather than getting select star or select all the columns, I'll just grab a couple of columns. You know, that should be obviously more efficient. Let's data over the network, for example. Let's run that. And guess what? 24 million rows scans again. Isn't that odd? Here's where I say, pause here for where the 24 million came from. Now, I'd love to say, as I saw this, I went, oh, yes, I know exactly what the problem is, what the issue is, and I'll explain it now. This took me a fair while to nut out, and I had a few conversations with people inside Oracle, and there was a lot of head scratching going on, and finally we worked it out. And so I thought it'd be interesting to share with you here. It's pretty cool. So what happens is, did I put it here? I actually put some code in so we can go through it. Let's have a look at some of the stats about this table. The key one here is it's got 666,000 rows. We know that. It's got 1,271 blocks. And the average size of a row, because it's just a little tiny table, is 11 bytes. Now, what can we do with that? Sorry, excuse me, I've got yucky stuff in my cup. So what can we do with 1,271 blocks and an average row length of 11? The number of bytes available to you in a block at 8K block size is about 8,100. That's not exact, it's near enough. It's good enough. We got a couple of RTL slots and row header and stuff, but that's give or take rough. Divide that by average row length, and as you can see, we can fit about 736 rows in a block. Now, why is that significant? Here's a query which, I'll scroll back up. It says, I'm selecting row num. I'm selecting this 15 as a magic number, which I'll come back to, and 15 times the row num times the rows in the block from Joule. And I'm using this 736 divided by 15, adding 1 at the end. So this magic number is 15, and the rows in the block is 1530. It's just going up by 15 each time. Now, why would I do this? Well, the reason I'm using a magic number of 15 is, I hope I didn't clear the screen here. No. The array size in my session is 15. So what is the meaning of these numbers? What happens is this. As I go for my first block, I hit the block and I want to read 15 rows because my array size is 15. I read 15 rows and send them back to the client. I then stop because that's what the fetch size is. The client now needs to issue another request. The client says, yes, I want the next 15 rows. I come back to that same block. I skip 15 rows and get the next 15. So I've actually scanned 30 rows to get the 15 I want. I give them back to the client. The client says, give him a third set of 15 rows. It says fetch size of 15. I'm on the same block still. I skip 30 rows, get 15, making 45 rows, and send those 15 back to the client. So given that there's 736 rows per block, I'm going to do this, if we scroll down, approximately 50 times. 50 times 15 is about 730 rows per block. So by the time I get to the 50th time that I'm scanning, asking for 15 rows, I'm actually skipping 750 rows and then getting the next 15 and giving them back. The table scan rows statistic is actually a measure of how many rows we're not just fetching, but actually skipping over or encountering on our way to actually satisfying the query. So because my array size is 15, if we actually say what's 15 times row 9 plus the skip rows from Joule divided by that, it's approximately 19,125 table scan rows for each block in the table. So if I add up all these numbers here that you can see above, and that's just for one block, the 730 rows that fit in one block, I'm actually going to get a table scan rows figure of about 19,000. Now, how many blocks were there in the table? About 1,200. 1,200 times 19,000 gives me 24 million rows. So when I scan those 1,200 blocks, and in each block there's about 700 rows to scan, and I'm doing it with a fetch size of 15, those 700 rows are done with 15 scanned rows to get me 15 rows, 30 scanned rows to get me the next 15, 45 scanned rows to get me the third 15, and so on, all the way up to the end of the block. So that's where the 24 million comes from. That's how many actual rows we encountered, not necessarily sent back to you, but encountered during the processing of this activity. One way, obviously, of improving that would be to change the array size. Rather than going back and just getting 15 and skipping 15, let's go back and get 100 at a time. As a result, because there's 700 rows in a block, we're only going to repeat our footsteps, so to speak, over that one block 7 times. So by doing it set array size of 100, I got just down to 4 million now. There's still that overlap, but it's dropped from 24 million down to 4 million. And that's the demo. So that's a key thing to remember when you're looking at the table scan rows gotten statistic. It's not actually a measure of how many rows you've encountered or how many rows you've fetched with table scans. It's a measure of how many rows that the table scan operation encountered in trying to find the information that you are asking for. So that explains the statistic. The big question is, if I can't go scroll all the way back, but what about the first demo, where when I did select star, or when I did select all the columns, I didn't see 24 million. I just saw 600,000. I had none of this information. Well, that was the cause of much of the discussion inside Oracle about why those numbers were coming out. I didn't put any slides on this one, but way back in Oracle 10, we introduced an optimization that we didn't really publish that well. It's called row shipping. And what row shipping is rather than the database grabbing a row off the table and dividing it up into its bits and pieces and columns and sending them back to you as attributes, row shipping says, we've got the row directory in the block header. The block header says where each row starts. All we need to do is actually grab those bytes that constitute each row and just send them down to the client in effectively SQL+. As a result, we actually are doing an optimization to bypass all the concept of digging into a row, digging out the columns, bits and pieces. Now, row shipping back in Oracle 10 was turned on if you selected more than 80% of all the columns in the table and nothing else. Now, we've changed it, I think back in Oracle 11.2, we changed it to being 100%. So when I do select star, I get this row shipping optimization where I don't actually have to revisit rows to break them up into bits and pieces because I'm just using the row directory inside the block to ship the entire rows down to the client, and his job is to actually just break them out into bits and pieces. All the columns, like select star, I can do row shipping. If I list out all the columns, which is the same as select star, I can do this row shipping. If I don't list out all the columns, like I did in the example there, then I go back to the database doing all the work in breaking out the bits and pieces. Or if I do anything which is not one of the columns, like that simple expression of X, then the same thing happens. The database becomes responsible for piecing out all the bits and pieces. So there's nothing you need to do to enable this or turn it off, but it's just a cool little thing I thought that, unbeknown to me, that this was a great level of discovery that in trying to work out why a statistical value went wrong, I learned more about that statistic, but also a really cool optimization called row shipping, which has actually been there. It's turned on by default. And yeah, if you do select star or select all the columns, then we'll use this row shipping optimization. That's pretty cool. I'm not sure if that would constitute a recommendation that if you need 9 out of 10 columns from a table, you're better off selecting all 10 anyway. That's perhaps for a later discussion. Obviously, you'd be impacted by maybe additional data over the network, etc. But it would be an interesting exercise at that really pointy end of performance, whether you actually might want to consider looking at doing something like selecting a couple of excessive columns or surplus columns to get the benefit of row shipping. Let's go back to our slides. So that's table scan rows gotten. I hope you found that interesting. And this is it. This is the last one for the day, which is what comes after the bracket. And this question came in. I thought this was a really cool question. There was someone who was fairly new to the database world or the DBA world. And they said, they said it was pretty simple. They said, I create a table called T. It looks like that. And it says table created. They were doing it in SQL Developer. And then I click on the SQL tab, which actually generates the DDL for that table. And they said, I was expecting to sort of get that back. And there are preferences in SQL Developer in which you can actually do that. But they got back the create table command, followed by all of this kind of stuff that you have at the end of a create table command. And they said, can you explain all this stuff to me? Because I'm fairly new, and what do I, you know, what do I choose for all these values? Now, for those that are thinking, please tell me he's not going to go through them. Yes, I am. But if it too long didn't read, you know, if you're on the TLDR, you almost don't need any of them, in my opinion. But I thought I'd explain each one because this is really more of a bit of a trip down memory lane as to where these things came from and how they came to be, and why a lot of them nowadays are pretty much redundant. But I wanted to actually talk about each of these things in turn, and I thought we'd draw some diagrams as well. So we're going to start off with %free, if I can spell, and %used. Now, most people are familiar with this, so we'll do this nice and quickly. It's pretty simple. A block starts off empty, and for lack of a better term, we fill it from the bottom, and eventually it gets to a point which we call %free. By default, that's 10% of the block. And the reason we do that is what happens is people may come back later on and take an existing row and want to update it. And they want to make that row larger. So the row is now going to go to that size. Obviously, it can't fit back where it was. And so that row will actually be relocated to here in the %free area. And that space there becomes free for smaller rows to go back in. That's what's called %free. The reason, even though this is a very simple concept and most people are familiar with it, I wanted to actually talk about it because the default, as I said, is 10%. And when I go help customers, what I find is just about every table I have is set to %free 10%. But the reality is, think about how many times do you actually have rows nowadays that actually update and get larger? It's actually not that common because in what I always used to call the good old days, we used to actually, be very cautious about the amount of space our databases used because space was a premium, it was expensive. Nowadays, things are a bit different. We get told, whatever you do, save everything. So tables nowadays become very much more exclusively insert. And if they're not exclusively insert, it's generally insert and delete. Updating rows where the rows actually become bigger still can happen, but it tends to happen fairly rarely. It's more those kind of things, what I call workflow or life cycle rows, where you have a bit of information to start with and then you add more information as the row sort of ages. But that's a fairly niche case. The most common example is just we insert data and we save it and we query it. So I wanted to speak about %free because think about that the vast majority of your tables, I wouldn't be surprised if you might want to set to %free 1. You're still receiving a little bit of space in there for a little bit of growth, and that can be useful in terms of managing transactions and the occasional update. But the reality is, I'd think seriously about using %free 1 or %free 2 as your default, and then adjusting to other values as time goes on. Now, %used came in when effectively a block became full. It had crossed that margin. So I'll draw another block here. So we've got a block which actually has crossed the 10% threshold. So it's grown up to here. And then someone comes along and does some deletes. And so we start creating free space. And eventually that block should be available to be reused. It's emptied to such an extent that we want to actually reuse some of the space. And that's what %used was. And we used to set that to 40. In fact, we still set it to 40. Once again, I would generally almost ignore that nowadays. In terms of a setting that we probably would use, you can almost, I say almost ignore it because with the advent of a thing called automatic segment space management, we actually now have bitmaps which represent the state of blocks. And those blocks have a little bitmap on them. I think it's 4 bits if memory serves, which effectively indicates that a block is 0, 25, 50%, 75%, or 100% full. Now, that bitmap maintenance is a very, very useful and efficient way of managing whether a block can be reused for its space. And the reason that is useful is when we get onto a thing called FREELISTS. And percent used used to be a critical statistic to make sure your free list management was under control. And so what I'll do is I'll talk about that next. I'll tackle these things out of order. So where I'm at the moment is percent free. Yes, you should be setting it. And in my view, probably setting it to 1 or 2% for most examples where you're just doing insert. Percent used, I'd be generally inclined to more or less forget about in most cases nowadays. So that's the first two we've covered. Let's go to a new page. So let's now talk about free lists, because I mentioned that briefly on the last one, and free list groups. This is why I said, let's get my camera work correct. This is why I said this is a bit of a trip down memory lane. Way back in the day, back in Oracle 7.3 and before, and Oracle 8, you would have a table, you'd create a table, and initially you'd be given an extent. So this is an extent, not a block. And an extent consists of a number of blocks. Now, obviously, these blocks start off as all being empty, and the database needs to know what blocks can be used as data starts coming in. So we used to manage this. It would actually have a thing called, I'll draw it as a list, a free list. And that was effectively information that stored what blocks were available. So there's B1, B2, 3, 4, and 5. The free list would say, yep, we got 1, 2, 3, and 4, and 5 if I could care to draw. As, for example, block number 1 became full, this guy would be removed from the free list, such that as we need to allocate space for new blocks, the database comes along and says, I need to add some more data. Block number 2 is on the free list. It's available for use to put rows into. And so we would start putting rows into block 2. When it hit its percent free limit of 10%, it would be removed from the free list, etc. So the free list was just a way of managing what blocks were free at the initial and what blocks became free as you deleted data from them. As you can imagine, if you've got lots of people inserting lots of data all the time, well, now you have contention for these things because you've got lots of people trying to put things on or take things off the free list. So we introduced the concept of allowing for multiple free lists. So you could have multiple free lists on a table such that you would spread some of that contention around. Now that works pretty well until you had a thing called parallel server. You may know it better as rack, but back in the day we called it parallel server. And that is multiple nodes actually coming along and wanting to attack, for lack of a better term, the free lists. Because one of the motivations for parallel server or rack was you've got a very, very high throughput machine. You need to throughput demands. You need to get a lot of insertions done, a lot of activity done. You've got thousands and thousands of transactions going on in rapid fire. Even with free lists, the problem now is you've now got a common resource that multiple nodes need to access. And even with rack nowadays, we generally know that that introduces what we call a lot of cache fusion activity. Back in the earlier days, it would introduce a thing called pinging, which was a lot of disk-to-disk operation as multiple nodes competed for a common resource. So that's when the concept of free list groups came in. So you would actually have free list group 1, free list group 2, etc. And each individual instance on a rack or parallel server node could actually be given dedicated access to a particular free list group. In that way, we didn't have a lot of cross-instance chatter for managing all this kind of stuff. But as we said, all this stuff is now managed with automatic segment space management, one of the big initiatives when Oracle 9 iRack came on. And in fact, cache fusion plus the fact that we introduced automatic segment space management is probably one of the reasons we renamed parallel server to being real application clusters, because real applications, in most cases, could be run on rack without doing a lot of careful analysis of how they were going to run. There were still some other issues you need to be careful of when it comes to contention, but free list groups and free list management is pretty much now a solved problem. So you can pretty much forget having to set them as well, which is nice. This is the objective of making the database easier as life goes on. Next page. So we've covered %free, %use. We've covered free lists and free list groups. Then we came up to inittrans and maxtrans. In a given database block, we allocate a bit of space for what's called the interested transaction list. You'll see the term ITL. And for example, here I've got 4 of them. This is the number of concurrent open transactions that can be active on a particular block at any given point in time. So that might be session 1, this might be session 12, and so forth. They can have uncommitted transactions going on inside that block at a given point in time. Once they commit, they'll free up their transaction slot or interested transaction list, and therefore it becomes available for someone else. Inittrans was allocating how many of these you got when the block was created. As the block, or in fact, when you allocated a new block for this particular table, how many slots do I want to resolve in advance? It used to be default to 1. I'm pretty sure now it defaults to 2. Even if you set it to 1, you get 2 in the block no matter what. Can't remember when that came in, but you get a couple no matter what. Maxtrans defaulted to 255, which is the maximum number of transactions you can still have on a given block, but you could set it to lower. In my lifetime as a DBA, I cannot remember a single place that ever set it to anything than 255 for maxtrans. I was trying to think of reasons why you might. All I could think of is if you, for example, back in the days of a parallel server environment, you might want to set maxtrans maybe to make sure you didn't get too many operations going on a single block at the same time. You just wanted to basically force them to wait rather than get into sort of a contention hell. But that's a very rare niche case. I can't remember anyone doing that. What people used to do back in the parallel server days is set %free very, very high, such that we'd have minimal people competing for the same block. But yeah, maxtrans, anything less than 255, I've almost never set. I think back in 11.2 now, we've pretty much deprecated it. We still support you putting the syntax on there, but no matter what you do, I think you can actually grow to 255 no matter what. So you can pretty much forget that one. Inittrans, as we said, I think it's set to 2 now, even if you nominate it as 1. We just always want to have that second slot available. You can choose to set it to perhaps 3 or 4 or 5. It's pretty rare. One thing you might choose to do it is to actually set it to a number slightly higher than 2 if you're being very aggressive with your %free settings, to make sure you're not going to run out of transaction slots for concurrency because you've deliberately chosen to use up as much possible space for data in that block. But once again, 99% of applications out there can quite happily get away with the default for inittrans and definitely the default for maxtrans. So guess what? You probably don't need them either. Let us continue. I'm going to keep an eye on the time as well. So next on the list were no compress and logging. These ones people are familiar with, so we'll fly through them. No compress is the default. The other option you have is compress, which is a facility. Now you might be thinking, oh, this means I have to pay more licensing. No, we have different levels of compression. I'm not going to dwell on these because there actually is a compression office hours, which I hope you've all been attending. So we have basic level compression and we have advanced level compression. And under advanced, there are various permutations. The basic one is free, part of Enterprise Edition. And the cool thing is that works only for direct path loading. And that's the key thing I wanted to speak about here is if you're using compression, don't forget you only get the benefit of compression for direct path loading when you're using the free compression. We have heaps of questions on asktom, people saying, how come my table isn't being compressed? It's only compressed when you do direct path load or alter table move. Logging, as you can imagine, makes a lot of sense, does all my changes go to redo? Once again, if you set something to no logging, Back in the old days, we used to call it unrecoverable, which was always somewhat of an alarming term. But yes, no logging, once again, direct path operations only. Don't ever forget that the implications of no logging are on if you have a standby database, which hopefully everyone does. In 18C, we've improved things better, but certainly before that, no logging operations can have a dramatic impact on your standby database. And as a result, no compress. Think about compress, especially for data warehouse kind of stuff. Often not used and should be. No logging, logging the default. And as you can imagine, you generally want it to stay like that. Next page. Now we get into the interesting ones, which was storage. I had the luxury of scribbling from what I showed you on the slide before. So storage came up with initial, next, min extents, max extents, percent increase, the free list, which we've already talked about, buffer pool, which I'll come back to maybe on a separate page, flash case, and cell flash case. Okay, we might come back to these. Let's talk about these ones next. First, initial, you can choose an initial size, say 10 megabytes. You could choose a next size, say 50 megabytes. These used to be important way back in the day, because back in the day, there was a ceiling on how many extents you could have. On an 8K block size, you had 505 extents, and that was it. The reason for that was, at the start of every table, we had a thing called the segment header. There was one block at the start of the table, which actually had in it where all the extents were. Extent number 1, extent number 2, etc. That's an 8K block size, and as a result, we could actually fit 505 entries in that segment header. That's why there was a limit. Way back in Oracle 7.3, we introduced the concept of a segment header being able to point to a thing called an extent block or extent map block. So the first 505 would go in there, and then number 506 could go in there, 507, etc. And thus, max extents unlimited came into being. As a result, before that, you chose a next extent such that you thought, well, I don't want to ever get too close to that. So you wanted that to be suitably big such that you never hit that ceiling. Nowadays, pretty much not an issue, because that's not an issue. Initial extent size, pretty much not an issue. The motivation for this goes back to way back in the days when we didn't have disk arrays. You actually had physical disks. And so by choosing a large initial size, you would get contiguous allocated space on the disk, which would be good for full table scans. I would challenge anyone nowadays that has a single disk for their Oracle database or Model 2 disks. Normally you've got 5,000 disks and they're shared amongst 12 other databases with 35 other applications on some SAN that you've never seen. So initially next, pretty much no drama anymore. I would generally use what we call locally managed table spaces with system allocation, which means you'll get 64K extents to start with, then megabytes, then 8 megabytes, then 64s, and so forth. It's pretty much managed for you. As a result, you don't need min extents, you don't need max extents. Percent increase was just an abomination, a terrible thing we did, which was you could choose initial of 10, next of 50. Percent increase of say 50 would say, okay, the next is 50. The next one after that would be 50 plus 50%, so 75 megabytes. The next one after that would be 75 plus 50%, so 120-ish, somewhere around there. So this was designed that each extent would be slightly larger than the previous one, which generally led to all sorts of fragmentation dramas and therefore, once again, a waste of time. So we got buffer pool, flash, and cell flash cache. Let's talk about them, and then we'll be pretty much done with the parameters. Buffer pool. Let's put it on camera. Your options were default, keep, recycle. In early versions, the very early versions of Oracle, memory was like most of us think about memory. New stuff comes in at one end. As it gets old, it gets pushed out the other end. LRU, least recently used. That was a disaster if you did a full table scan, because everything that came in full would flush out all your good data and throw it away. Early versions, we introduced a thing called small table threshold, which said we realize that full table scans are going to cause that problem. So if you do a full table scan on a table larger than that, we'll simply add them at the end and throw them away straight away, because the likelihood of a full table scan being of benefit to you is low. So we did that. Then people said, well, that's fine, but what about tables which are full table scans, which are slightly larger than the small table threshold? What if I want to keep them? Well, you could allocate a particular section of the buffer cache called the keep pool. Similarly, if you were doing, for example, large index range scans on objects, well, they could still flush at everything because they weren't full table scans. You might want to make sure those things, those big, large index range scans didn't flush everything out. So you could put them in a dedicated area called the recycle pool. That's where those things came about. In Oracle 8.1, we introduced a much, much more intelligent thing, which we put rows, all rows come in effectively at the middle. As they age down, we actually record how many times they've been touched by applications doing queries on them. When they get to here, if they've been touched a large number of times, we promote them to the hot end. This is what we call the touch count algorithm, and it pretty much does away with the need for that. It does away with the need for that. So once again, all these buffer pool parameters, you can pretty much ignore. Dare I say, we've made that management autonomous. We've automated it. It's now managed very, very well. Literally since 8.1, I've almost never, ever seen the need to set buffer pools. Which leads me to my last two before we run out of time: flash cache and cell flash cache. Only applicable for, generally applicable for Exadata. The flash cache, number one, is a recognition of the fact that flash is a very, very cool technology, and it's generally a bit cheaper than memory. So you've got your buffer cache here, which might be, say, 200 gigabytes. But you could, for example, have 4 terabytes of flash on a database server. As stuff gets aged out of the buffer cache, normally we would have to read it from disk again. Well, maybe we just put it into the flash cache here. So it's like a secondary buffer cache. It's slightly slower, but obviously a lot larger. That's the flash cache. You'll see it referred to as a database smart flash cache. That's a facility that can be used on Exadata and on other databases as well. Cell flash cache is a recognition of the fact that in an Exadata box, we have a database server and we have what's called a cell server, something that actually holds the disks. These are just basically compute nodes for the database. These cell servers used to come with just lots of disk as well, but now they come cranked up with a whole stack of flash on them as well. So unlike the database flash cache, which is as things get aged out, what this is as we read things from disk, we can read them into the flash cache as well and then provide them to the database server. When someone comes eventually and says, I need that data back from disk again, we can actually give it to them from flash as opposed to the flash cache. This is pretty much automated. You can control it using cell flash cache, but Exadata systems can automate that usage as well. So there we have all the different cycles of stuff here. Now I'm going to have to hack my webcam here to get us back on screen. One moment. So we've got a few minutes left. You can see we've covered %free, %use, all of these. We covered all of these. Table space users, I'll come to you in a second. I didn't get time to cover this one because we're almost out of time. So as you can see, what I'm really recommending is, for the vast majority of the time, all you really have to do, in my view, for most applications, is set %free and set the table space and maybe compression. And I think you'll be good for 99% of your applications. Most of the other things are just as I said, a trip down memory lane, a historical look at some of the things we've had that you had to manage in the past. So I'm going to wrap it up now, and I'm going to leave you with this. I saw this on Twitter today, which is, do not deploy this week. This week is not a good week to deploy. And it's true. Hopefully this close to Christmas, or whatever you celebrate over this holiday season, if you're not a celebrator of Christmas, hopefully if you've got some time off, take that time off. I know you're probably just like me. You're an IT geek and you love working with databases, and I'll probably do a bit of work next week, but don't do anything seriously production level next week, because the last thing you want to do is have your family being upset with the fact that you're passionate about IT because you don't get to spend time with them. So I thought I'd leave that up there. Merry Christmas from the asktom team. And the last thing, I'll stop the share and bring me back on. And so the last thing I'll do is I'll get my champagne glass out. I just thought I'd toast all you and the office hours program. Oh no, it's going to go over. So thank you very much for attending all the office hours this year. I hope you got some value out of them. Have a very safe and very happy holiday season. And I'll see you in 2019. Bye for now, everyone.